Here we have the definition of the derivative. Let's have a look what happens if we have two functions and we add these two functions. Let's call the two functions f and g. We want to show that the derivative of the sum is sum of the derivatives. In a more accurate writing, f plus g as a function, derivative at x, is equal to f at x plus g at x, derivative of the terms. So if we have two functions, f plus g, and we compute the derivative at x, the definition of the derivative is here. This is the limit of h going to 0. And here we have what we differentiate, that means this sum at the point x plus h. So this is f at x plus h plus g at x plus h minus what we differentiate at x. We differentiate f plus g. So this is f at x plus g at x divided by h. Now we split this fraction into sum of two fractions, each of them giving the derivative. We copy the first term, fx plus h, and we write the third term, minus fx, plus, and we can divide this into two separate fractions. The second term, g at x plus h, minus the very last term, g at x, for h going to 0. And now we use the theorem that limit of sum is sum of limits if the limits exist and are finite, are proper, which we assume to be. So this fraction, when taking the limit for h approaching 0, is the definition of f derivative alone. And the second fraction is the derivative of g at x. So this concludes the proof that the derivative of sum is sum of derivatives.